Hello and welcome to my channel. In this channel, we explore statistics in architectural research. I am Dr. Louis Diaz. In this video, we'll be diving into lesson 17. In this lesson, we'll be covering the completely randomized design. The objective of this video is to help you understand when to decide on using the completely randomized design in agricultural experiments. Let's get started. Completely randomized design is one of the simplest designs in agricultural research. This is one of the simplest, and also this design is whereby the treatments are assigned randomly to the experimental units, whereby your treatments, you assign them randomly to the experimental units, and also is whereby all the experimental units, they have equal chance of receiving a treatment. All the experimental units, they have equal chance of receiving those treatments. And the other thing, when we talk about the completely randomized design, is whereby there are no blocks or no groupings. You don't group your experimental units, no blocks or no groupings. So now in this one, we are saying that is one of the simplest. That's the first thing. And the other thing is the treatments are assigned randomly to the experimental units. Then the other thing that we classify this design is all the experimental units, they have equal chance of receiving the treatment. They have equal chance of receiving the treatment of interest. Then the other thing that we talk about in this one is there is no blocking or there is no grouping of your experimental units. Let's go to example. For example, we are feeding chickens. We want to know the effect of diet. Feeding chickens to investigate the diet effect. Now, we want to see whether this diet influences the growth of chickens, for example. Now, remember we spoke about the treatment. So the treatment diet, we are going to have different levels. Treatment are going to have level 1, level 2, level 3, right? Now in this level we spoke about the issue of control. One of the videos will talk about the control. Maybe we'll say treatment 1 is our control group, then treatment 2 and 3, these are our different levels of diets. Now maybe here we are saying is a treatment group, then here is 20% of our diet, then the other one is 50% of our treatment interest. Now what we have to do, remember we have those pens where we are going to put our chickens, right? These are our pens. Now in these pens we put chickens randomly. Now what are we saying is, when we are using the completely randomized design, we take these treatments randomly as well. We put them in these pens. We can take, for example, just randomly we take any treatment there. Then treatment 3, 50% of our diet of interest we put in this pen number A. Then on pen number B, just randomly, maybe the control group. The treatment 0, which is the control. Then randomly, we put the treatment of 20%. Remember, in one of our videos, we also spoke about the replicates, which means whatever we are doing here, maybe in your experiment, you are going to repeat it 4 times or 5 times. And in our video of replication, we spoke about the minimum must be 3 for replication of your experiment. So the way we allocated these treatments in these experimental units, because the experimental units, remember, is whereby the treatments are assigned, the experimental units. So these pens, we classify them as our experimental units. So now the way we allocated these treatments is random. The way we allocated even the chickens inside the pens is also randomly. So we are trying by all means to follow what is called the assumptions of completely randomized design. So now, if I'm going to the assumptions of this experimental design, one of the assumptions that we have, we are saying that, let's say assumptions, we are saying that all the experimental units are homogeneous, are the same. When I'm saying all the experimental units are the same, I mean all these pens, they are the same. You don't notice any differences between the pens that will influence your observations. Remember, in this experiment, our observations is to look on how the chickens grow with the influence of the diets. So if there are no factors that they make these experimental units to be different, we are saying that on the assumptions, all the experimental units are similar. Then we also have the limitations, because in these designs we have the assumptions and also we have the limitations. So in this one, the limitations is, once, let's say limitation, if it happened that you made a mistake by saying all the experimental units are the same, that will result to the error of your experiment, the result to error. Because now when we are receiving the growth performance of these chickens, you may think that the performance is caused by your treatment, only find out the performance is caused by the factor that you didn't notice when you were assigning your treatment. So it's very important when it comes to completely randomized design to make sure that all your experimental units are the same, and also those experimental units, they all have equal chance of receiving the treatment of your interest. It's one of the simplest, as we indicated before. The assumptions of completely randomized design is the experimental units are homogeneous, which means all the experimental units are similar. Everything is the same, is one of the assumptions for completely randomized design. Then, after the assumptions, our focus will be the general linear model. When we are talking about this completely randomized design, our model is Yij is equal to mu plus Ti plus error Ij. Now, in this model, we have Yij, which is our observation. Remember our example, we look at the effect of diet on growth performance. So our observation is the growth performance. The growth performance of the ith treatment on the jth experimental units, which means in our case on the jth pen, because our experimental units are pens. That's where we put the treatment. Then we have the mu, which is our overall mean. Then we have the ti, which is the treatment effect. In our case, our treatment, we have diet. Our diet is treatment 0, treatment 2, and treatment 3. These are our diets. Then we also have EIJ, which is the residual error or random error. Is a residual error. So this is the general linear model for completely randomized design, whereby you're saying Yij is equal to mu plus Ti plus error Eij. So the mu is overall mean, the Ti is treatment effect, and Eij is our residual error. To recap, we have covered completely randomized design. In completely randomized design, all the experimental units are similar, and all the treatments, they have equal chance of being selected.
Do you have a topic you'd like me to cover, a question, and maybe you want a clarity on a certain topic? Leave a comment below. Do not forget to subscribe, like, and share this video.
See you in the next one.